You deposit $250 each month into an account earning 3.5% interest compounded monthly. Part A, how much will you have on the account in 30 years? Round to the nearest cent. To answer this question, we will use the annuity formula shown here below, where A is the account balance after T years, PMT is the regular deposit amount, R is the annual interest rate as a decimal, N is the number of compounds per year, and T is the time in years. Because we're looking for the account balance in 30 years, we are trying to determine A, where A, the account balance after 30 years, is equal to this quotient where we have PMT in the numerator. PMT is the regular deposit amount, which in our case is $250. And then we have times, and then in parentheses, we have the quantity 1 plus R divided by N raised to the power of NT, where R is the annual interest rate as a decimal. The interest rate is 3.5%, and therefore R is 0.035. This is divided by N, the number of compounds per year. The interest is compounded monthly, and therefore N is 12. And the sum is raised to the power of N times T, where N is 12 and T is the time in years, and therefore T is 30. And then we have minus 1, close parenthesis, divided by R divided by N, which gives us 0.035 divided by 12. When we're evaluating a complicated fraction or quotient on the calculator, we should include parentheses around the numerator and denominator. So let's include a set of parentheses around the numerator, and notice how we already have parentheses around the denominator. Now we go to the calculator and enter the quotient. We have open parenthesis 250, open parenthesis, and then 1 plus 0.035 divided by 12, close parenthesis. This is raised to the power of 12 times 30, which is 360. So we press the exponent key, and we can enter 360, or we can enter 12 times 30. Let's enter 12 times 30. And now we press the right arrow to exit the exponent, and then we have minus 1, and then close parenthesis, and then another close parenthesis for the numerator. And then we have divided by, in parentheses, 0.035 divided by 12, and enter. To the nearest cent, the account balance is $158,853.19. So now we know in 30 years the account balance will be, again, $158,853.19. Part B, how much total money will you put into the account? Will you deposit $250 each month for 30 years? And therefore, the total money put into the account is $250 times the number of months in 30 years, which is 30 times 12, which is equal to 250 times 360, which is equal to $90,000. And for part C, how much total interest will you earn? To determine the interest earned, we take the account balance after 30 years and subtract the total money you put into the account, which is $90,000. So we have 158,853.19 minus 90,000, which is equal to $68,853.19. So this is the amount of interest you earned over the 30-year period. I hope you found this helpful.